Hello. At MyGenius we have received many requests for more information on how to create and add new luminaires to our Bloom Unit lighting library system. In this, the first of two movies, I want to show you how we prepare a non-aimable light fitting for uploading to our library system. Now, any version of SketchUp can be used for this task, but we do recommend using SketchUp 8 as we're doing here, because that way the objects created with this version will be compatible with all the other current release versions of SketchUp. Now, there's three items we need to have on hand for creating luminaires in Bloom Unit. Firstly, a photometric distribution file in IES North American format of the light fitting that we're creating. Secondly, an image file of the luminaire to be used as a thumbnail for the library menu. And thirdly, the 3D model of the luminaire, which in this instance is a converted file from a manufacturer's in-house CAD system. Now, for Bloom Unit we need to assemble our fixed or non-aimable lights in an inverted position, and we can make this change by firstly select the geometry of the luminaire and using our SketchUp flip tool to flip this along the vertical axes. Now, another item that is very important, particularly with converted or imported models of luminaires, is that we need to ensure that the size of the model is correct. So we simply can do this by measuring a known dimension on our light fitting. In this case, the ceiling trim diameter is showing as 19.55 centimeters. And in fact, I know that the dimension here should be 7.7 centimeters. So if we enter 7.7, SketchUp has a very useful feature where it will ask, with the edited dimension, do you want to resize the entire model? And in this case, we certainly do. Okay, now if we move back up to the model and now moving to a side view. The thing that we want to do here is that we want to set this horizon line, or in fact the origin plane, to act as our insert plane. Now, to help us there is that we can choose camera and then go from perspective to parallel projection, so we can more clearly see the fixture geometry in line with the origin plane. The issue here that we now need to carefully consider is that where do we want to have our insert point or insert plane. Now, something I prepared a little bit earlier is a sample section of ceiling which is at the origin plane here. So using window, layers, just want to turn on that ceiling section. Now we can see here that going back perhaps to our side view, is that the ceiling is actually in line with the face of the trim ring, which would not be the case. The fact is that this ceiling trim needs to be clear of that ceiling plane. Now, in order to help achieve that, is that we need to move our luminaire model so that it is just clear of our ceiling plane here. So now when we look back at the trim is clear of the ceiling, but you will notice straight away that there's another item here, which is that the ceiling plane is going to cut off the view of the internal of the downlight here, and also quite possibly cutting off or blocking the light output from the photometric file. Now, SketchUp has a very useful feature here which is called cut opening, and a brief explanation is that with a cut opening option selected, is that any enclosed shape around the center of the light fitting, but also exactly in line with the insert plane, will create a hole in the surface that it's mounted into. We want to create our shape, which is going to become the opening within the ceiling every time we put this light fitting into our scene. Now, if the trim edge here was in line with the origin plane, that's all we need to have, and the creation of this light fitting as a component will use that trim edge to cut the ceiling. But in actual fact here, and somewhat deliberately, is I've chosen something just clear of the ceiling trim so we can see a more certain way of dealing with this. Okay, it's probably a very good idea to now set the face style under View, Face Style, X-Ray. So now we can see all the internals of the model. We want to create a circular ring just beyond the inner diameter of the trim ring. Okay, to do that we simply need to use our circle tool, place it over the vertical axis line, which is the blue one here, is holding down Shift, which will hold that orientation, and then click on that so we know it's on the origin point and origin plane, and we want to drag it just beyond that inner trim edge. Now it'll make it easier if we just zoom in here and pull that just beyond as we have here. Now we have created a circular disc here, and we don't need the surface component or the fill component of this, so we just simply select the surface and delete it, but you'll note that the outer ring is still there. It's perfectly in line with what will be our insert point, and that's all we need to do to have this prepared for the cut opening option. Alright, so now jumping back here is that we now have all the geometric elements for creating our light fitting. Okay, if we jump back to our side view, is that the next thing that we want to do here is to consider that for the Blue Minute luminaire is that every light fitting for that library needs to be made up of two primary components, and that's called the base component and the head component. The base component is always the component that mounts into mounting plane or onto our trunnion arm or onto our mounting point. To set this up accordingly, first of all we want to break the model up into all its basic components, and to do this we simply explode the model, and here we see our model is broken down, leaving us now to select and create our two primary components. Now first of all, we're using a Windows Select, is that we are selecting the base component, and you'll notice just that it also includes that ring that we created exactly in line with what will be our insert point. Okay, so we simply right click here and we make component. Okay, so as we said before, this component always needs to be called base, B-A-S-E, and we want it to glue. In other words, when we place it near a surface, it will snap to a surface. And in this case, we could just select horizontal, but to give us a bit more flexibility, who knows, you might want to mount it into a wall, we will just say any. Okay, now very important here is that we set the component axes. Now you'll notice that currently the component axis is in line with the edge of the what would be the bottom of the of this assembly. We want to move that to the origin point. Okay, to do that we select component axes, move the view so that we can see our axes more clearly, and now clicking on and seeing the highlight as origin, which is exactly where it needs to be, and then in SketchUp to set the origin you select the origin point, then you select anywhere along the red axis and then anywhere along the green axis, and there we are, it's set. Right, so now we have this cut opening option, so we want to check that, and we want to replace the selection with this component. We don't want it to disappear on us and have to try and reinsert it back into the same point. So here we are. So there we are, we're showing a boundary box around that part of the luminaire. Now to help track the various elements here, it's very useful to have a dialog box open called Outliner. So if we turn that on and bring that into view here, we can see that base is now properly defined. Now the thing is that we want to use the remainder of the fitting will become the head. So using the outliner properties here, we will take the base and just hide it. Now moving back so that we've got a clear view here, we can now quite happily select the rest of the luminaire, right click, make component, and this one needs to be called the head. Now the alignment information is really not relevant now because it will be embedded into the base, so it's not needed, so we won't bother putting these together. If it was an aimable head, then we would need to set the component axis, but that will be covered in another movie. Okay, so now we just create that, and we notice that our head is now appeared in our outliner dialog box, and you see the boundary box. If we unhide our base, we see the two components together. Okay, we now have all the geometric components that we need for our light fitting. The only thing that is missing now is the light source. So to create the light source, we need to go into our Bloom Unit Luminaire Manager, as we've done here, and we need to go into Custom, and we want to add our light fitting. So it will come up with a unique name which you can leave as it is or type in something that will be more recognizable for the work that you're doing. So here we have our mythical manufacturer called AB underscore, we'll say DL for downlight, 27 watt. It doesn't matter as long as it's a unique description. You can put what you like in, although I always try to name the light sources with an underscore ls at the end of it. Alright, so we have our light source or light fitting. Is that the first thing we need to do is now go and look for our IES file. Now we have this file stored and available for this. So with that selected, and we open that. Okay, you can see the rated lumens here, which is the, this is a lumen output which is picked up from the IES file. Here we set an area light type. If we don't change it, leave it at none, it will just simply treat it as a point source. It's probably a good idea here to have it as a disk source, so it will act more accurately. It will be an area source rather than a point source. Now in this case, because we have a 7.7 centimeter diameter trim, we have a 6.4 centimeter diameter internal dimension of the trim, is that it would seem that a 50 millimeter disc would work very well here. And by coincidence, this is actually set at 25 millimeter radius, 50 millimeter diameter, so it's exactly what we need. We have the feature here of hiding the source if we need to do that for some reason. We don't need to do that here, and you don't need to do it most times. Okay, another level of configuring the light source is clicking on the output option here. We can set the color temperature of the light source. The default is 3000 degrees Kelvin. We'll just change this to 2500 degrees, which will give us an incandescent color. We also have the facility here to adjust the lumen output. Now the thing that we need to do is to, we have our light fitting defined, is to place the light into our scene. So we do that with place, and you'll notice that there is outline here, and we'll just put the insert point very close to our origin plane. Now if we switch this off, now you'll notice on the outliner that our light source has now appeared, and it is also confirming the IES file that it is made up of. Now zoom extents, and maybe just rotate this around so that we can see this a little more clearly, is that the shape here is the shape of the photometric distribution. It doesn't designate its power or size. This is just a default size that we use for light sources so that it becomes more clearly visible when you place them into the scenes. And also, if the distribution is asymmetric, then you can clearly see which way the beam is oriented. Alright, the thing is too is that this has placed the distribution in conventionally pointing down. Again, we need to select this to invert it so we can place it as part of the light fitting. Okay, so if we click on that, again, just flip it along the blue axis, you can see that this is now turned it around the right way. And if we go to our side view here, we can use our move tool and now move the distribution to very close to where it would be we want it positioned inside our light fitting. Okay, now looking down here is, and let's zoom closely up here. So the disc that we created before is right in the along this this boundary line. So we still have a little more adjustment to make here to position that where we want it to be. And so in creating these light sources, you need to decide whether you would like to have the point of the photometry either outside the fitting, as we're doing here. But of course, if we do that, the source disk will always be visible and it won't look like it does in the real world. So the point is here, we need to drag that back, and probably just putting it in line with the bottom of the reflector will be best here. It's always worth just checking this from various sides to make sure it is in the center. If we have a top view, and we can see that it is very close to exactly where we need it to be. And we can see here the disc, the source disc, and it's a good idea to make sure that the edges of that aren't hidden by the reflector geometry, and then we know it's working the way we want it to. Now move to the side and we'll just zoom out. We now have all the components that we need for creating our light fitting here, but we haven't quite finished. Is that we have our base, and as we said, the base and the distribution need to be subcomponents of that base, and that's simply achieved by, in this case, selecting the head and dragging it over the base to become a sub-assembly of that base. And then we have the lighting distribution itself. We just simply need to drag that over the head, and we can see that our light fitting is now properly configured. And when we select the base, the head and the light source and so on are all selected at the same time because they are subcomponents. We can always verify that we have the right IES file by expanding the light source line and looking at that here. So now we have our light fitting assembled and ready for exporting Bloom Unit system. Okay, is that we need to now pull in a plugin which is called Light Maker, and it is a facility that will automatically create the necessary elements and structure of the lights so that these can be imported straight into the Bloom Unit lighting database. So the first thing we need to do here is, because we have our light fitting selected, we can go import custom light info. So we press that. Now the only text information that's available is the name of the light source. Now you can just simply overwrite with whatever you want to name as the light fitting. To show you where this might appear is that if we open our Luminaire Manager, jump into, let's say, Concord, Sylvania, Indoor, let's pick Impact, we can see this is the name that will appear in there, and then we have Luminaire option, which will come up underneath here, recessed LED downlight. So you can type in whatever you would like to see in those fields. Okay, so we can just simply AB LED downlight. Is that the description could be 27 watt LED. Keywords are just fairly obviously words that can be used to search the lighting database for for fittings that fit certain categories or certain selection criteria, and you can type whatever you want in here and just separate it with a comma and LED and so on. I won't spend too much time on that. Now this dialog is quite important. This folders is the name and the structure of which the luminaire will be organized within your portion of the database. Going back to our luminaire manager, and for example, so going back to Concord Indoor Impact, is that you'll notice here Concord Sylvania Indoor. So what we need to put into here is that, let's say your manufacturer name is AB and / indoor, and with that it will create exactly the same structure or arrangement as we're seeing with the example, the impact example that we've picked there. So the thing is that you can have the category could be indoor, outdoor, hazardous, street lighting. That's completely up to you, and you can have if you wanted to even sub directories of that too, and you just simply drill down to that position. So this is where you need to control the manufacturer name and the categories and places how this needs to be arranged. Alright, so here we have an option for aimable. The light fitting is not aimable. If it was, we could do some test aiming just to make sure it's working properly. The glue to any, that is something that was imported from the custom light info, so we almost never need to change that. Here is our thumbnail that we spoke about a bit earlier, and here we have a pre-prepared image file, and then we just open that, and that is what is going to appear in the menu system, which we see here, and the image is also going to appear up here. That is where it gathers that information from. Okay, the other item here is this UUID. That's the unique identifier that's used between the application and the server, telling it exactly which light fitting to use. Now, because it's a new light fitting, we do not need to put anything in here. But if it is a light fitting that you want to edit later on, is that you place the existing version of light fitting in the scene, select it. When you import light info, it will put in the UUID so that you can edit, re-export that, and it will replace it when it's uploaded by the BlueMunit programmers. Okay, then we have export directory. This is where the location zip file, which has all the necessary components, is going to export to. So in here I've created a subdirectory called export, and there's been a few previous versions I have generated. That's what the assembly of the components go into these zip files. So here, for instance, so we're putting it into this export, so just simply tell it that, and you'll see that name highlighted here. Very important is that we could now press the export button, and it will create all the elements for our new light fitting, ready to be very quickly uploaded to the BlueMunit library system. But it is a very, very good idea to make sure that you save the light fitting before you do that, because the export function does change the file, and it makes it very difficult for trying to use it later on if you want to do any updates or edits. So it's always a good idea to save the file before you do the export. So we'll just tell it to save, and when we're ready, we just press export. So you can see here that there was the export function. If we jump into our export directory, here is the latest file that was created. So that's our file, all set to be uploaded to our BlueMunit Luminaire library. Now I would like to finish off this session by highlighting what makes BlueMunit so unique. Only BlueMunit provides the true rendering quality of area light sources, including the accurate simulation of cuttings and openings for recessed or regressed luminaires. And only BlueMunit allows us to truly evaluate the combination of highly detailed scenes complex materials using actual light source color temperatures, which includes the contribution of a physically measured and constantly changing sun-sky model. These features are simply not available with any other type of lighting analysis software, but they are essential ingredients in our work and communication with both our colleagues in the design community and the very large number of downstream stakeholders. Thank you.